The close relationship between computer science and visual art can be surprising for most people. In fact, computer science and artificial intelligence have had an impact on almost every field of art. Architecture is one of the general examples where art and science meet. The laser scanners that detect the authenticity of paintings, whether or not they're original, is a specific example of the relationship between artificial intelligence and visual art. However, I am more interested in the impact of computer science on the making of visual art. What kind of contributions have been made? And what would the future of this relationship look like? But first, how does the artist benefit from computer science? The greatest tool for artists is their imagination, but it is limited by their knowledge. Computers supply three basic tools for the creative artist: access to information, software, and new ways to interact. In the arts, software can have a variety of uses that range from implementing the artist's ideas to creating ideas. Computers can blend things that may not have any obvious relationships and can make real things we did not think of before. Deep learning algorithms and AI assistants are examples of the sophisticated technologies brought to us by the interaction of tools. The artist may experience what was previously unimaginable and be able to share it with their audience. Let's take a look at a small fraction of the contributions of computer science to the making of visual arts. The first example we have is generating original works of real artists. This technology depends on deep learning algorithms, which is, in short, when machines can learn basic concepts and apply those concepts in situations other than the ones in which they learned them. This technology means we can generate a new original work from Da Vinci's, Munch's, or Picasso's works. The example we have here is applied to the works of the Dutch artist Rembrandt. The process goes through four main steps. The following is an oversimplified explanation to these steps. The first step entails gathering the data from the artist's collection of paintings through many different sources, including 3D scans and abstract images, using a deep learning algorithm. In the second step, we determine the subject of the painting. It is clear that most of Rembrandt's paintings were portraits, so it was useful to analyze the demography of the faces in these paintings. Looking at factors like gender, age, and head direction, the data led to the conclusion of what characteristics will the portraits have. And then the whole painting would be extracted from just data. The third step generates the features. These features are extracted by statistical analysis and learning algorithms, and then based on that, it is possible to create the basis for a typical Rembrandt painting. We bring the portrait to life in the fourth step. Because a painting is generally a 3D picture, the depth of the features was incorporated into the painting and printed by a 3D printer that uses a special paint and printed many layers, one on top of the other, which resulted in the height and texture of the final painting. For a more detailed explanation, you can search for the next Rembrandt. The second contribution we have is creating realistic animations from single static image. This technology benefits sometimes from a technology called deepfake that depends on machine learning and artificial intelligence. Using a technology like deepfake, it is possible to bring life to static images. A simple example would be bringing life to the woman in the Mona Lisa. You can see how she is moving her head here. A more useful example is demonstrated in the deepfake Salvador Dali Museum in Petersburg in 2019, when this technology helped bring life to Dali and enabled his animation to interact with the visitors. In 2016, a more sophisticated technology was used in visual effects to bring to life a younger version of the character Tony Stark by collecting pictures and videos of the actor who played him and creating a living, realistic animation from that. The third contribution is the neural network art. To simply explain this technology, we can say it makes use of deep learning to create networks of algorithms that can learn from supplied data. The networks of these algorithms simulate the neurons of the human brain and are arranged in a way that makes it possible for them to create new art with minimal work from the artist. The most popular tool that uses this technology is Google's Deep Dream Generator. In 2015, Google opened a physical art show using this technology. When we think of animation, we think of simple 3D design software and the animating process. But the truth of the matter is, the relationship between sophisticated software and sophisticated animation is much more complicated than that. In 1994, the team working on The Lion King faced a problem with the scene where hundreds of animals will be running at the same place. The problem was, with the developing animation techniques then, the animals in this case would collide with each other. A new program had to be written for this scene, and it took 3 years to write and finish and animate the scene properly. A more recent example is seen in the 2012 movie Brave. In that movie, the character called Princess Merida had curly hair that Pixar wanted to look as natural as possible. At the time, the hair of 3D characters used to move as a one piece with the head and did not look natural. 2 additional software programs were specifically developed for this movie by Pixar in a span of 3 years. One of them allowed simulation of Merida's 1,500 strands of hair curls to move together with her movements. You can see in this video how she's moving freely and that her hair is moving very naturally with her movements. There is no question that computer science and artificial intelligence will continue to impact the making of visual arts. But what about negative future outcomes of this relationship? While computers excel at cognitive tasks, they are doing so in the realm of data processing and pattern recognition. AI plays more of a feature role in these last examples, but it is still the case that a human is necessary to set the wheels in motion for every artwork. In the near future at least, AI is set to play a positive role for artists of all varieties. Perhaps we will soon find a world in which computers tackle most of the number-crunching, data processing, repetitive and boring jobs, leaving us to take things in different directions, to think outside the box, to do more creative work, and to do the unexpected. Thank you for watching and listening.